Have you ever wondered, are we alone in the universe? Have you ever contemplated the possibility of an infinite universe teeming with life? This enigma has captivated humankind's imagination since our ancestors first gazed upon the stars. From the ancient Greeks to the modern space age, we continue our cosmic exploration, forever hopeful that ET will be answering our call. Today, we're continuing our search for life beyond Earth, fueled by curiosity and wonder, a search that transcends space and time. I'm Grace Trafton of Cupertino TV Productions. Stay tuned and hear what a SETI scientist has to say in answer to our question, where are the aliens? SETI is an acronym that stands for the Search for Extraterrestrial Intelligence. This remarkable nonprofit research institute was founded in 1984 and is located in Mountain View, California, in the heart of Silicon Valley. To quote their own words, the SETI Institute's mission is to lead humanity's quest to understand the origins and prevalence of life and intelligence in the universe. We're very fortunate to have as our guest today Dr. Simon Steele, an astrophysicist who's the Deputy Director of the Carl Sagan Center for Research at SETI, and a science educator and communicator for over 25 years. Welcome to our show, Dr. Steele.
Thank you very much. It's a pleasure to be here and to visit our neighbors, Cupertino TV, which is just a few miles down the road from the Institute.
Dr. Steele, are there any other research facilities besides SETI that's searching for alien life in the universe?
There are, but none that are dedicated totally to the search for life, and life in all its forms. The SETI Institute, by the virtue of its name, the Search for Extraterrestrial Intelligence, is how the Institute was founded 40 years ago this year. But it's expanded its search, if you like, to take into searching for life in any form in the universe, any life that did not originate on Earth itself. Now, there are other centers around the world that are doing SETI science, as we call, looking for signals or evidence of alien civilizations. There are some in the United Kingdom, there are some in other countries in Europe and in Australia, and in the US. But ours is the only institute just doing that, and so it is unique in that way.
It certainly is unique. Now, since Mars is the closest planet to Earth, is that the best place to start our search?
Mars is a good place to start. You might as well start next door. And so it's interesting that I put up a picture of two views of Mars and Martians. Of course, the idea of Mars being populated by intelligent civilizations goes back quite a long way. A famous American astronomer, Percival Lowell, part of the Lowell family of Massachusetts, really got excited about the idea of life on Mars, and this was back in the 19th century, and built a telescope out in Flagstaff, Arizona, called Lowell Observatory, and he thought he identified canals on Mars. And canals, of course, are artificial waterways, and his theory was that the Martians were taking the water from the ice caps and irrigating the planet. It turns out not to be the case, and modern science, now that we've sent landers to Mars, turns out that there are indeed ice caps made of water, but there is no sign of intelligent life. Of course, Lowell's work inspired H.G. Wells to write War of the Worlds, and in 1898 the Martians came and invaded the Earth, and that was all sorts of problems. In fact, the Martians landed in the book War of the Worlds very close to where I grew up, so it's close to my heart,
yes.
and where the Martians came. But of course, the real invaders now are the humans invading Mars with rovers like Perseverance rover, looking for signs of ancient fossil life. There's no intelligent civilizations on Mars, sadly, but Mars was a very similar planet to the Earth a long time ago. It's gone through a very different evolution to Earth and has lost a lot of its surface water. But there may be evidence of early fossil life on Mars, and that's what we're going to be looking for.
So we haven't given up on Mars at all?
Haven't given up on Mars, I think, and of course a Mars planetary scientist may well argue with me. It's pretty sure that there's not much alive on Mars now. So the hope is to find fossil evidence, and that's what the Perseverance rover is doing at the moment. It's collecting samples from a dried riverbed or delta, actually, on Mars, and ultimately those samples will be collected and brought back to Earth for analysis.
That sounds very exciting. Now, the moons of Jupiter and Saturn sound like they're more promising places to search for life. So what plans are there to explore these bodies?
Yes. Now, we are pretty certain you need water for life. Water is an amazing, even though it's so abundant here, we take it for granted. It's such an amazing molecule. And in order to build complex life out of molecules, you need them to be able to move around, and you do that by having those molecules floating around in water. And so if a planet is dry, you may well have all these lovely organic molecules, but they're just going to sit there and do nothing. So the idea is water is very, very essential for life. And so what should you do? You should look for worlds that have water. Mars used to have water, and that's why it's good to go back and look. Venus has no water whatsoever. Neither does Mercury. Neither does Jupiter or Saturn. They're big balls of hydrogen. But the moons of Jupiter and Saturn are worlds roughly the size of our own moon. And they are icy worlds. They've got an icy crust, but beneath the surface, they have warm oceans, which is quite amazing.
They're still warm?
They are still warm. And it's interesting that they get warm, or they keep warm, because of gravity. The gravity of these giant planets and the moons and the sister moons going around the planets stretch and squeeze the moons like rubber balls, and that heats them up. And it melts the ice, and so you have warm oceans, even though you're so far away from the sun. There are two moons especially that are very, very exciting, and I put up a picture of Enceladus, which is a very small moon of Saturn, but it has an icy crust, and just beneath it is this warm ocean. And in this glorious image from Cassini spacecraft, you can see these jets of water being shot out of cracks in the surface, which is very exciting.
Oh my goodness.
And so there's a chance of actually looking at the chemistry of these oceans underneath the surface of Enceladus. Moving closer to Jupiter, Jupiter has a moon called Europa, which is the same thing. It's about the size of our moon, but it has more water than there is water on Earth.
Oh my goodness.
It has this gigantic ocean. We don't know anything about it, but in October of this year, a spacecraft called Europa Clipper is going to start its journey out to Jupiter, and we'll do an analysis of the surface and the ice and the chemistry of Europa. It's not going to get there until the 2030s, so it's a long way out. It's a good long journey ahead, but it will get there. And SETI Institute scientists are involved in the Europa Clipper mission, which is very exciting.
That must be exciting.
What they're also involved in is not only the mission itself, but also to make sure that Europa Clipper is clean. There are types of life on the Earth that's very, very resilient to bad conditions. And you could send a spacecraft all the way to Mars or all the way to Jupiter, and there'd still be Earth microbes alive. And what you don't want to do is send your spacecraft to a place that you're looking for alien life, taking your own life with it.
Taking your own
because
life.
Then all you're going to discover is stuff you brought with you. And so the concept of keeping these spacecraft pristine is a science called planetary protection. You are protecting the life of other worlds from human microbes, and also protecting the Earth from alien microbes when you bring samples back. And that's a very, very important part of exploration, that you do not mess up the life that you're going to. The SETI Institute is involved in this idea of planetary protection as well.
Now, how about way beyond our solar system? Where and how do we go about looking for life? It's such a big space out there.
The sun is a star. It's our only star. It has its planets going around it, but the sun is also a constituent of a galaxy. We call it the Milky Way. The Milky Way has 300 billion stars.
300 billion.
Which is a number that is just ridiculously large.
It is. Hard to comprehend.
Hard to comprehend. You imagine every grain of sand on the beaches of Earth, and you've got big, big numbers. There are a lot of stars out there. If you look up in the night sky, and you're lucky that the sky is dark, you see the Milky Way as this band across the sky, and that's the galaxy we are living in. Now, recently, and I say recently because only in the 1990s, were the first discoveries of planets orbiting other stars. We suspected that there were planets orbiting other stars, but no evidence was there. But the technology, astronomy is a very technology-driven science. When the technology was there to look at stars in the galaxy, there was an ability to start detecting planets orbiting those stars. And it turns out that there are probably planets orbiting every star in our galaxy, pretty much. There's a few exceptions. So if there's 300 billion stars, there are 300 billion planets.
At least.
At least, because we've got quite a few in our solar system. There's no reason why others don't have as many. And of those, some of them will be Earth-like. And by Earth-like, we mean small and rocky with oceans around a star that is giving up just enough heat and energy to keep that water from either not boiling away too hot, not freezing because it's too cold. There's going to be billions of those planets out there. And so it's, you know, the idea is that there are so many stars and so many planets that it would be very, very strange indeed if a lot of those planets were not teeming with life.
Exactly, exactly. Now, I had read that Voyager 1 is now the most distant human-made object in space, and that it's 15.2 billion miles from Earth, B, with a B. Can you tell us more about Voyager 1 and 2?
Voyagers 1 and 2 are ancient spacecraft. They were launched in the late 70s.
So that's called ancient.
Ancient in space exploration. And they were sent out to explore the outer solar system. They are twin spacecraft. They are traveling at very, very high speeds, 40,000 miles an hour, out into space. Voyager 1 and 2 passed by Jupiter and Saturn. Voyager 2 sailed past Uranus in the late 80s, and then Neptune in, I think, 89, 90. Don't quote me on that. And then out into deep space. And they have been traveling now for that period of time, since the late 70s, at very, very high speeds. Voyager 1 is now twice as far away from the Sun as Pluto.
Oh.
Now Pluto, I know it's not a planet, it's a dwarf planet, but we all know and love Pluto as a planet. Pluto is a long way away. It's 40 times further away from the Sun than the Earth. Very, very cold, distant planet from the Sun. And Voyager 1 and 2 are now almost twice as far from the Sun as Pluto as they head into interstellar space. So they're now leaving the protection of the Sun and the solar system and heading out towards the stars. There's a couple of things very interestingly. If they happen to be heading in the direction of the closest star, which we know is called Proxima Centauri, it would still take Voyager about 15,000 years to get to the closest star.
goodness.
It's a big, big distance. The
Yes.
distance between stars is immense, and that's perhaps food for thought in whether aliens, even from the closest star, and we know Proxima Centauri has its own planets, to travel at very high speeds to Earth. 10,000 years is a long, long time for a space mission. Now,
Yes.
maybe they've got higher technology. We don't know if warp drive exists.
Right.
We like to think so because it
Right.
makes TV shows easier. Nevertheless, the technology to get between stars is incredibly difficult, and that is another argument to say, let's look out to where they are
Yes.
and not wait for them to come to us.
Right, right.
Yeah. Carl Sagan and Frank Drake was one of the founders of the Institute, decided they would put a message on these spacecraft. And it's called the Golden Record, and there's a picture of the Golden Record. It is a record. For a while, people didn't know what records were because they were lost in time as well. We know what
Right.
records are.
Right.
And then CDs came, and then
Right.
iTunes and everything. But records are coming back now. My son loves vinyl. So it was an actual record made of gold. Gold is a very stable element. And this was put on the side of the Voyager spacecraft. And what it carries are sounds of Earth. It has recordings of voices, recordings of whale song. It has a few very, very simple video segments. Of course, this was 1970s as it was developed. Should any alien civilization find this spacecraft, there is instructions on how to play it. And
If they can read their
If they can read
instructions.
the instructions, and this is all assumptions. So it's possible that will give them a message from Earth. This is called METI, Messaging Extraterrestrial Intelligence. It's slightly more controversial. The SETI Institute doesn't do that. We wait. We don't broadcast. But in a sense, it's more a statement of us as humans. What do we want to say to the stars?
Right.
What do we want to say to others? And so it's a reflection. These messages are a reflection of humanity and what we think are important. And I think that's important as well.
Now, while preparing for this program, I came across two words that I wasn't familiar with. One was biosignatures and technosignatures. Can you briefly explain to us what they mean?
Yes. What we are looking for is when we go to Mars, say, or Europa, or looking at planets around other stars, it's difficult to find a microbe on another planet because they tend to be rather small. And most of life, we suspect, is probably going to be microbial life. Life on Earth was just basically simple organisms for billions of years. It's only
Right.
very, very recently that more complex organisms appeared. So if that's common, it's very difficult to say what is normal
Right.
when you only have a sample size of one. It's not very easy to draw a graph with one data point.
Exactly.
But probably there are going to be many more planets with basic microbial life than cities and spacecraft and intelligences. And so what you would want to do is see how the microbes on those worlds affect the planet that they're living on, because they do. And when you think about the Earth, and we're all sitting here breathing lovely, fresh oxygen.
Hopefully it's
Hopefully,
fresh.
yeah, it's maybe not as fresh as it used to be.
Right.
All of the oxygen in our atmosphere is produced through photosynthesis by algae and by now trees and so on. You can't have oxygen, as far as we can tell, in an atmosphere without life. The reason is that oxygen is a very reactive gas. It'll react with anything. If you put a lump of iron in oxygen, the iron will rust because you're creating an oxide. So oxygen will react with its surroundings incredibly quickly. And so if you just have a little bit of oxygen and there's nothing creating more of it, it'll be used up in various chemical reactions, rusting stuff and things like that. So if you have a consistent level of lots of oxygen, you need a source of that oxygen. And as far as we know, and that's always a good term to use, as far as we know,
Right.
there is no way you can create an atmosphere of free oxygen without life. What does that mean? It means that if you point a telescope at another planet going around another star, and this is what the James Webb Space Telescope is trying to do, and you detect oxygen, then that is a sign that there may well be life on that planet. Now, we haven't found life, but we found what's called a biosignature. It's a signature, it's a fingerprint of life, that there may be life there. Proving that there is life on that world is much trickier, because you probably need to go there. So that's what a biosignature is. And the same thing on Mars. If you're looking for methane, things like that, methane is produced by digestive systems of animals, but it's also produced in volcanoes. So if you detect methane as a gas on Mars, it could be a sign of life. It could not be. Nevertheless, methane is then a biosignature. It's a signature of biology. And so a biosignature is detecting primitive life. Now, if you use a radio telescope, as the SETI Institute does, radio waves are not produced by creatures, by microbes, but they may well be produced by technologies. And so a technosignature is a signature of a technology. And that is what SETI is. You are searching for a signal that suggests that that is artificial, cannot produce naturally, and therefore there has to be an intelligence behind the signal. And that is what a technosignature search is. Now, we use radio waves, and in this illustration, there are lots of things that produce radio waves in space. It's very, very... Radio waves are everywhere. They're just filling space from various things. Aurorae, the northern lights, produce a lot of radio waves because they're electrical discharges. Lightning produces a lot of radio waves. Black holes remarkably produce a lot of radio waves, and the best way to study black holes, and that's another show. We can come back and talk about black holes. Radio telescopes are very good at detecting black holes. And of course, aircraft emit radio waves, and cell phones and satellites emit radio waves. And so you have to sort through those for radio waves that can't be produced by nature. A lightning strike gives out a pulse of radio waves, but that's a natural phenomenon. Whereas if a satellite downloads its images, say something studying the sun, when that information is downlinked to the ground, then that is a technosignature. It's a sign of technology. Unfortunately, that's the technosignature of humans. And what you need to do is separate that out and look for those signals that can't be produced by nature. It's not produced by black holes or exploding stars or aurorae. It's obviously artificial. And then you have to make sure it's not human artificial. And once you've cleared all of that stuff out of the way, then you can say that's something we need to look into. And this goes back to Carl Sagan's, you need to be very, very sure that the signal you're detecting is A, can't be produced by nature, and B, is not produced by humans.
Right.
And then that's when the excitement starts.
Could you very quickly tell us about Carl Sagan's book, which he had written, that's called Contact, and it was made into a movie in 1997, I believe, starring Jodie Foster. Now, why did this book and movie have particular significance for SETI?
Yes, Carl Sagan wrote Contact, which is a wonderful book, and it is about the first contact with an alien civilization that sends information down, detected by a radio telescope. Matthew McConaughey and Jodie Foster. So if anyone hasn't seen it, it's a really good film. The first half of the book is actually quite accurate in how humans would detect and try and decipher a signal. The second half of the book, of course, is going into hopes and fantasies. What's very interesting, of course, is because of Carl Sagan's connection with the Institute, he based the main character, Jodie Foster's character, Ellie Arroway, on a friend and colleague, Jill Tarter, who is a SETI Institute astronomer.
Oh, my goodness.
Jill has retired now. She's on our board of trustees and is a very valued advisor, but she was the model for the character in the film.
Oh.
Again, if you see the movie, it features a couple of very important radio telescopes that are real radio telescopes. One's called the Very Large Array, not a very a clever name, but it's a very large, and it's array, meaning there's lots of telescopes joined together to work in unison. And there's a picture there on the screen of the VLA, and that's in New Mexico. And we are still using that telescope to detect technosinuses. And the other telescope they use is called the Arecibo Observatory. The Arecibo Observatory is in Puerto Rico and was one of the best telescopes in the world, not only to receive signals, but it also had the capability to transmit signals. Sadly, due to very bad weather, a hurricane passing over Puerto Rico, that telescope was damaged beyond repair a couple of years ago. And so we have lost an iconic, not a movie star, but also one of the best radio telescopes in the world. And there are hopes and plans to rebuild it.
Just want to ask you very quickly a last question. Do you think that we can ever decipher a message from a space alien?
That is the big question. We don't know if we will ever decipher a message from aliens. And the best we can possibly hope for is to recognize that it is a message. That when we get a signal, we confirm that it's artificial, that it's not human, it wasn't by one of the Starlink satellites, by mistake. We then have to look at patterns in that signal. And if there's a pattern, rather than just beep, 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 then that pattern we have the ability to recognize as syntax, as language. May never, as we say, be able to decipher what they say, but we know that they are saying something. And that means that there are other intelligences out there, not too different from us, maybe physically, maybe they look like octopuses, but the basic ideas and concepts we share. We share an ability to communicate, we share the passion to communicate, and that means that we're not alone in the universe.
Thank you so much for being with us today, Dr. Steele. This is a wonderful, fascinating topic, and we will continue.
Thank you. I have enjoyed myself, and we'll be back.
The question remains, are we alone in the universe? Or are we part of a cosmos teeming with diverse life forms? Another question also remains, why has humankind been searching the skies since the very beginning? Perhaps it has something to do with the search for understanding of our own existence and our own purpose. A British physicist, Professor Brian Cox, has said, when we look into space, we're looking into our own origins because we are truly children of the stars. Our many thanks to Dr. Simon Steele and to the SETI Institute for pursuing this never-ending enigma. The search continues. Thank you for being with us today, and see you next time. Bye-bye.